Good morning, good day, and good evening to all of you who have joined this session. It's a pleasure to present to you today a topic which, from my perspective, is one of the most crucial topics for the digital transformation in oil and gas industries. And it's the level of sensors we are talking here in this session. Every process relies on sensors, relies on information, and without this information, we cannot optimize any process. We cannot improve sustainability, improve efficiency. So this topic here could be quite of a crucial topic to open the path to the next level of process operation in oil and gas industries. So I have already introduced by my nice moderator, but actually I'm coming in the field from gas analysis and liquid analysis from various industries where we are measuring the composition of gas and liquids from a quality, safety or environmental perspective in various processes. And I'm now doing portfolio management for various digitalization solutions, starting with condition monitoring applications, with data science and artificial intelligence, and remote and wireless connectivity. So a complete range of ways how to optimize customers' operation and services. So also in the presentation, I will give you different insights where I see potential for optimization on the field of sensors. And I'm now doing global consulting for many customers worldwide, where we implement digitalization solutions there, focus on sensors again, on different sensors. So that's kind of my role. So I give you a bit of insights all over the world in different aspects of the oil and gas industry, what we can do to achieve the next level of operation. So my goal for this session, or my personal goal for this session, to make one main message clear. If you want to optimize your process to make it profitable, you have to rely on analytical devices, on instruments like temperature, pressure, flow in the field, and on new IoT sensors there, which provides you the information to control any kind of process. And of course, always the question is, does these sensors provide you information which are always available, which are accurate and precise in such a way that you can really trust? And that's why I always talk about reliability. You have to know how the sensors are working, if they will work the next 24 hours, because if this information is missing for your process, it has impact on your quality, on your output, on safety and environmental aspects. So this is quite of a crucial topic there, of course, to lower your operational costs there, regarding service, regarding energy costs, regarding material consumption, and of course also to increase the product yield, regards quality or output. So any process control relies on information provided by sensor, classical information, temperature, pressure, flow, level, which is in the plant, information from gas and liquid analysis of the composition of different measured components there. So you can really optimize your process. You can control if your quality is good enough, if you fulfill environmental requirements. You can check if your explosion gases in the process are too high, or for example. So every information we need there for a process. So we have to make sure that the process control relies on this information. I often see in various plants that there's some kind of a misunderstanding there. So process control expects this information. On the sensor level, it's not possible to provide this information, always accurate, always available. So process control starts to ignore some information, which reduces the quality of information and quantity used by the process. And of course, in worst case scenario, have a negative impact, because there was a reason why these sensors were installed in a process, why they was purchased by someone. So if the process control starts to lose the trust on the provided information, this will have quite of a crucial impact. So I say today, most of the processes in the world cannot really trust the sensor information in the field. And that's from several perspectives. We have sensors which are sometimes failing. Information is not available for the process. The typical example, it's one-to failure, the sensor is broken, control hasn't have the information, it could cost you millions. We have sensors out there which are very, very complex, and we will see it later. And they have to measure very accurate. So they're measuring parts per billion or parts per million. So if they're having only a small deviation, the information is not really usable by the process. So if the measurement is not correct or not close to the reality, it's a problem, right? And of course, every sensor or many sensors are impacted by the environment, right? I saw sensors there which having problems with humidity, with dust, with pressure, ambient pressure. So all these topics impacts also sensors. So if you have unreliable analyzers, instruments, or other sensors, you have problems. The process is running not in optimal state because your process is working with wrong information or missing information. The quality is not good. You may have higher operational costs, or your process yield might be lower than expected. So that's why we always try to focus with customers. If you want to do a digitalization project, do not only focus on artificial intelligence for process modeling, on optimization topics and so on. Giving you just the example of AI-based optimization of processes. The AI will fail if your information provided by sensor is not correct. The AI will calculate something completely different with the completely different information. So that's a very crucial information to ensure data integrity. So I want to give you 4 examples what we can do on a sensor level in oil and gas industry to optimize the information provided by sensor and to contribute to process optimization. The first topic we see, so we had with a customer, he had gas analyzers and liquid analyzers in the field in an ethylene plant, in one of the big ethylene plants worldwide. And there was a topic of accuracy. Accuracy, we will come later to that, what exactly it means. But first, let's look into the process. In many processes, we have the challenge between quantity and the purity of the produced chemical composition in the end. If we are producing more, the purity is going down to a specific point, and that is a kind of a challenge we have to solve. Of course, we want to improve the quantity or the quality, depends on the produced product. But if we want to optimize the quantity, we have to make sure that still the product fulfills the minimum quality specification from the process. And we often see that customers define their process set point with a high safety tolerance. In such a way that they know, okay, the sensor is maybe not providing exactly the information I need. I maybe do 10% additional on top of that 20%. So I have a big space actually, because the process information is variating and so on. And they are driving the process like this. And it's working, it's fine. But there's a big gap of information not used. And if you want to optimize the quantity, you will have, of course, impacts on the quality, but still you have to check with the sensor you have installed if the quality is still fulfilled. So you have to make sure that the measurement provided by the sensor is accurate, so you can trust the information. So if the sensor says to you, you have 5 oxygen molecules in your process, it has to be 5 oxygen molecules and not 5.5, not 4.5, not 5.2, and so on. So this is a kind of a challenging situation. So you want to have this accuracy of your complex sensors there to give you the insights and the possibility, the room to optimize the quantity, but still be always sure that the minimum quality is ensured. So let's look into one of the use cases. That's, for example, a gas analyzer there in the field, which is measuring a lot of composition there. So this kind of analyzer, it has to be checked on a regular basis. And now we are talking about a complex device there. So this complex device has to be checked every week at minimum, sometimes even every day, because it is impacted by many different conditions there. You have to ensure the measurement is accurate. If that's fulfilled, this information, this gas analyzer or liquid analyzer provides you a really helpful information for your process. And what we often see is that we are far away from the real value from the process, and also the measurement is not repeatably available for the process. So what we have done with this customer here, we are optimizing, first of all, the way he's checking the accuracy of his analyzer. So we are optimizing the way he provides a gas to the analyzer, a reference gas, to really check how close is the measurement from this analyzer to the known composition in the gas. So we are optimizing this task here to do that in a frequent way and often every day. And then we are applying statistics on this information, on this collected information, using the potential of statistical quality control. So different control charts like QSUM, EWMA, Sheva charts known from the process control side, and applying here on quality data and applying different statistics for the participants, well known about statistical process control, routes like the Western Electric ones, as an example. We are applying this statistic on this data, and what we identifying is here, and you see it in the screen in the end, this pattern, we have here a really abnormal pattern of data, right? The screen points are validations every day. So we are seeing this data are fluctuating a lot, which would be normally not recognized by any human technician in the field. But we software can identify it. If you have 10,000 of this routines done every day, a human technician cannot do that. A software can do it, and the software recognizes here, hey, we have here really an unusual pattern, right? Fluctuating points up and down, sometimes not really normal distributed. And then, of course, we see, oh, the first points are violating some limits set by user, so it's getting critical. Normally, then the process in the normal phase would just run with this information. The analyzer result could not be really used because it's not accurate enough. So the process would maybe stop it, maybe ignore the information, maybe work with wrong information. So this would be one of the problems we see. And this is with predictive maintenance approach, you can identify really this type of issue in the field. And what we have saw with customers, they are using this approach only for gas and liquid analyzers in the field. They had savings more than several million euros per year, savings in such a way that they could improve their process output there. So optimizing accuracy of sensors, of complex sensors in the field, can provide several million euro higher process output every year. And the cost of the implementation, we are talking about 100,000 euro, maybe 200,000 euros. So far, far low for the hundreds and thousands of sensors in the end. So we see here within the field of sensors a value add that you can optimize the process output by 7 million euros per year and reduce maintenance efforts and increase availability of your assets there. Second use case, emission monitoring. A well-known topic is in the moment sustainability. Everyone talks about it. Every government in this world is setting up new rules for monitoring emissions in the industry. what most of or many users are unknown, there are very complex measurements available there, which is called continuous emission monitoring systems there, which are implemented in most of the refineries worldwide. These systems are very crucial. The government expects, for example, 98% availability of this measurement. And if you fail to provide this information and to document this measurement results, to prove that your plant is working according to environmental guidelines, it will lead to heavy penalties and, in worst case, a plant shutdown. So it's these sensors, or this big sensor, it's not a small sensor, it's a very big and complex sensor system. It's providing really mandatory information for you. The last 20 years, it was done run to failure still. Sometimes spare parts were at warehouse, sometimes service technician there with a lot of costs for everyone there. And suddenly they failed, then there was a big issue because these devices, sensor systems are very complex. They are not just like extracting it, plug and play. So you cannot just install a new one. So you have to have experts for that kind of measurement. And what we see, for example, as a trend, what you can do is you can extract information, other sensor information out of this complex sensor to predict if any physical components in this device is failing. And so by that, you can predict when maybe a downtime could happen, react upfront, and can by that fulfill that you always be aligned with your local emission guidelines. We'll not deep dive into that, but for example, we have done it with an emission monitoring analyzer here, where it has specific physical component there. One instrument consists here of various sensors there. So it's a combination of various measurements at once. It has internal sensors, temperature measurement, pressure measurement, electronics there, voltage measurement, and so on in this complex device. And with the help of experts defining rules, data science, statistics, and artificial intelligence, it is possible to extract information out of the sensor which are not used as all by today from these devices, and can really predict the failure of any physical component from these devices. So you can, instead having often 95% availability or 98% availability, 100% availability of the sensors, which is quite crucial. And some sensors like that in the field, they're having only 80% availability. So there's a high potential of improvement in the field by applying digitalization and data science on this information. So using more information out of traditional instruments and analytics in the field will provide your process additional value add. This was about monitoring, and what we see as a trend there is to model processes. Everyone speaks about it also within this conference there. So there's a potential to modeling processes there. And in this way, we are in this approach, we are having modeled the emission output of a complete plant. So we are collecting all the available sensor information there in defining specific models defined by experts supported by AI. And we are predicting emission values like CO, CO2, NOx, and so on. So information every government wants to have documented and monitored. So we can here really see what happens with the emission of a plant if we are, for example, increasing pressure, flow in the process to really simulate, can we somehow achieve a higher process output, for example, but still fulfilling environmental guidelines, or other way around, how we can keep the process performance in this like we have today, but reduce emissions there. And this is possible by building up a digital twin of a process, by simulating various process operation models, which is kind of a new topic for everyone in the oil and gas industry, but it's becoming more and more important because the pressure on environmental guidelines will increase every year. This is something which is quite clear. Third example, what a customer came to us was about remote control of pipelines. There was already a presentation about remote access, so I will more deep dive into the use case there. So the challenge was here, we have an oil and gas pipeline and we have sensors there mounted for pressure, temperature, and so on. But in some cases, they are maybe not connected to an overall monitoring system. So not every sensor is connected to automation system, for example. And this makes it quite often effort, right? Because you have to go there in a big distance with a service team. In case of a non-availability of this information, you have to know that. You maybe want to remotely monitor the sensors there, which are not connected to the automation system. But first of all, you want to have it for your service team available, that you have always access to this information and gets automatically triggered by a software in case of any downtime of these devices. So you can really plan your service activity. In best case, you can get the information in a predictive way and then get with the right spare parts there at the sensor side to support that. Again, the sensor information there we have there, they are very special. So in some cases, it's the classical sensor information, flow, pressure, temperature, level, which might be usable for a customer or maintainable, but some cases also the devices are more complex. The vendor service needs to be ordered at site, so there are many topics here. Here was natural gas transportation. Actually, we had several sensors there, and the way it was possible to monitor this information was building up a 5G network all over the plant, using classical 5G network, also enabling a cloud connection there, also other connection possible, like LoRa would be an option there, but in our case it was a 5G network there. And then we collected the information from the sensor, provided the pipeline operator and the service provider the information in a dashboard. What is the current status? They got the information from every sensor if there was any alarm, and combined with this predictive maintenance approach from the last example, he could really predict what happens there. So you can really connect hundreds and thousands of sensors to one system, separated from the control system, to make it available for your maintenance team to track the performance of these sensors there in the field. Last topic there. So the last three examples was about classical instrumentation analytics in the field, which is available in every plant there, which are connected to automation network in most of the cases, which is providing information there. But was more focused which information you can extract on top of that, which information you can use additionally in a more digitalization way, and which information you can use for optimizing sustainability. This topic here is a use case about about an IoT sensor there. So what we have here is any kind of rotating equipment in the field, for example, a centrifugal pump there and upstream, where you have which is available and which of course could sometimes fail. Not often, but if they fail, that's a problem there. So you need new IoT sensors there, because the traditional sensor approach would be too costly to install there. So you need a low cost, easy to install sensor with enhanced communication variants there. So what we have done here is to bring a multi-sensor on this centrifugal pump here, which is measuring the vibration of the rotating equipment, the wall vibration there, or temperature, for example, and is communicating this information to a good gateway. In this case, it was via Bluetooth, and then sending the information to a cloud-based software, which is applying artificial intelligence on it, and is monitoring how the sensor is developing. So this sensor sends the data there, Then AI model will be trained based on the collected raw data in different operational stages of the rotating equipment piece. And then there is an AI when the AI trained model will be is finalized, then the model runs and it informs the user whenever it happens. The sensor itself is only a small €100, so very, very low cost, very easy to use. And the complete raw data are used here for AI modeling. So this was also one of the topics there. In some AI models, it's better to have really detailed information, not only the single vibration monitored result, but also the complete frequency bands and so on. And also using here a sensor with a high battery power support, so a sensor which can run for 2 or 3 years in the field without the need of battery replacement. This was one of the requirements here. So I'm coming to the end of my presentation. I rather focused on giving you some insights in the field of sensors and not deep diving into that we can do in breakout session and so on. But my goal was to show today how reliable sensors are crucial for your process to optimize the overall process in regards to efficiency and sustainability. And we see we have different challenges for the sensors. They could fail, they are not measurement accurate, for example, they are impacted by the environment. So we have to take care about them with the usage of digitalization. So digitalization data science can provide a value add. That's clear for everyone who is there. It can also provide a value add on the field of sensors for the overall process. We saw that in the first example by having a higher process speed by several million euros per year. And also, besides the classical instrumentation and analytical measurements there's a need for IoT sensors there, for vibration, for energy, for temp, and so on. So the demand for IoT sensor will increase there. And for example, the vibration monitoring use case for rotating equipment can be really additional help for process operation to make sure that every asset in the plant can run in a good shape. Just to end the presentation, I can only motivate everyone who's joining in this conference to try out things. We see it in the field of sensors. There's a really slow development there in many cases there, especially on the classical sensor side there. So we're always motivating to users worldwide to just try it out, test it, test out the value add, make it in a pilot case reality, and then archify the business case to the management to archify the investments, which are often very, very small. The sensor budgets are very, very tight normally. So we are talking about solutions which can start for 3,000, 4,000, 5,000 euros, even less. On maybe 50,000 euros for a complete plant. So the investment is very low, but the impact could be very high for the process. And we have to make sure that process and sensor level are together, bring into a future. So thank you very much for your attention. And in case of any questions, of course, I'm available the evening or the next day.